In 1800, the explorer Alexander von Humboldt witnessed a swarm of electric eels leap out of the water to defend themselves against oncoming horses. Most people thought the story so unusual that Humboldt made it up. But fish using electricity is more common than you might think. And yes, electric eels are a type of fish. Underwater, where light is scarce, electrical signals offer ways to communicate, navigate, and find, plus in rare cases stun, prey. Nearly 350 species of fish have specialized anatomical structures that generate and detect electrical signals. These fish are divided into two groups, depending on how much electricity they produce. Scientists call the first group the weakly electric fish. Structures near their tails, called electric organs, produce up to a volt of electricity, about 2/3 as much as a AA battery. How does this work? The fish's brain sends a signal through its nervous system to the electric organ, which is filled with stacks of hundreds or thousands of disc-shaped cells called electrocytes. Normally, electrocytes pump out sodium and potassium ions to maintain a positive charge outside and negative charge inside. But when the nerve signal arrives at the electrocyte, it prompts the ion gates to open. Positively charged ions flow back in. Now, one face of the electrocyte is negatively charged outside and positively charged inside, but the far side has the opposite charge pattern. These alternating charges can drive a current, turning the electrocyte into a biological battery. The key to these fish's powers is that nerve signals are coordinated to arrive at each cell at exactly the same time. That makes the stacks of electrocytes act like thousands of batteries in series. The tiny charges from each one add up to an electrical field that can travel several meters. Cells called electroreceptors buried in the skin allow the fish to constantly sense this field and the changes to it caused by the surroundings or other fish. The Peters elephant nose fish, for example, has an elongated chin called a schnauzen organ that's riddled in electroreceptors. That allows it to intercept signals from other fish, judge distances, detect the shape and size of nearby objects, and even determine whether a buried insect is dead or alive. But the elephant nose and other weakly electric fish don't produce enough electricity to attack their prey. That ability belongs to the strongly electric fish, of which there are only a handful of species. The most powerful strongly electric fish is the electric knife fish, more commonly known as the electric eel. 3 electric organs span almost its entire 2-meter body. Like the weakly electric fish, the electric eel uses its signals to navigate and communicate, but it reserves its strongest electric discharges for hunting, using a 2-phase attack that susses out and then incapacitates its prey. First, it emits 2 or 3 strong pulses, as much as 600 volts. These stimulate the prey's muscles, sending it into spasms and generating waves that reveal its hiding place. Then a volley of fast, high-voltage discharges causes even more intense muscle contractions. The electric eel can also curl up so that the electric fields generated at each end of the electric organ overlap. The electrical storm eventually exhausts and immobilizes the prey, and the electric eel can swallow its meal alive. The other 2 strongly electric fish are the electric catfish, which can unleash 350 volts with an electric organ that occupies most of its torso, and the electric ray, with kidney-shaped electric organs on either side of its head that produce as much as 220 volts. There is one mystery in the world of electric fish. Why don't they electrocute themselves? It may be that the size of strongly electric fish allows them to withstand their own shocks, or that the current passes out of their bodies too quickly. Some scientists think that special proteins may shield the electric organs. But the truth is, this is one mystery science still hasn't illuminated. TED-Ed is a nonprofit. If you value our work, please consider supporting it on patreon.com/TED-Ed.